Hi guys, today we are talking about how the electronic configuration is done. But before talking to you about it, we want to give you some definitions. Niels Bohr, an important Danish physicist, in 1914 formulated the definition of orbit, stating that the electron can travel around the nucleus only a few circular orbits, on which it doesn't lose energy. Bohr establishes this equation to determine the radius of each orbit. The radius is equal to n, which indicates the main quantum number, an integer that can take values from 1 to more infinite, multiplied by h, which indicates the Planck constant, all divided by the product between 2 by Greek m, that is the mass of the electron, and v, the velocity. However, Heisenberg observed that while in the macroscopic world one is able to determine accurately all the quantities necessary for the description of the motion of a body, in the microscopic world there is a margin of imprecision related to the perturbation that the system undergoes due to the measurement itself. For this reason, Heisenberg formulated the principle of indetermination, which says it's not possible to determine simultaneously and with absolute precision the momentum and the position x of an electron. Therefore, Schrödinger formulated the definition of orbital. The orbital is the area of the space around the nucleus where the probability of finding an electron is greater than 95%.
Energy, shape and orientation in space describe the different kinds of orbitals which can be found around the nucleus of an atom. These parameters are defined by 4 quantum numbers: the principal quantum number n, the angular momentum quantum number L, the magnetic quantum number m, and the spin quantum number s. The n number suggests which energy level the electrons can be found in. The L number describes the shape of the orbital and can assume 6 values between 0 and 5 that corresponds to the S, P, D, F, G and H letters. For example, when L is 0, it is the S type, and when L is 1, there is the p-type and so on. The m number describes the orientation of the orbitals around the x, y and z axis, and the s number defines the direction of rotation of the electrons around its axis. Depending on the L number values, you can obtain a different region in space called the sublevels, each containing a given number of orbitals. And when it is S-type sublevels, there can be only one orbital. If it is P-type 1, there can be 3 orbitals. If it is D-type 1, there can be 5 orbitals. And when it is F-type sublevel, there can be 7 orbitals and so on. The electronic configuration follows 3 fundamental rules, which originated from the fact that every single atom obeys physics laws. The first one is the Aufbau's rule, whose principle dictates the way in which electrons are filled in the atomic orbitals of an atom in its ground state. As a matter of fact, you will have to fill orbitals starting from the lowest level of energy to the highest one. The second rule deals with the spin and how it affects the number of electrons inside every single orbital. This is called the Pauli exclusion principle and says that only 2 electrons, each one with a different spin, can exist in a single orbital. As you already know, some sublevels have more than one orbital, and every one of them share the same quantity of energy. They are called the degenerate orbitals. And thanks to the Hund's rule, you will have to fill each orbital with a single electron, and only after having the entire sublevel with half completed orbitals, you can complete them.
The periodic table of the elements allows us to get information about every existing atom in nature. It's composed of little boxes, each of them representing one element, and they are arranged according to the atomic number. As you can see, this is the box of carbon. This is the symbol of the element, which is composed of 1 or 2 letters. The first one is always capitalized. Some symbols derive from the first letter of the common name of the element, while others are based on various names of various origins, mostly Greek and Latin ones. This is the atomic number. It represents the number of protons in the nucleus of an element. As the periodic table reports information about neutral atoms, if you know the number of protons, then you also know the number of electrons, because in this type of atom they are the same. This is the electronic configuration. It represents the disposition of electrons of an atom or molecule in atomic or molecular orbitals. This is the electronegativity, a measure of how strongly the atoms tend to attract bonding electrons themselves. And this is the atomic weight expressed in atomic mass units. It indicates the average mass of an atom considering all its different isotopes. The isotopes are atoms of the same element having the same number of protons but different number of neutrons. The periodic table exists in many forms, but the most used is the one where the elements are organized according to their electronic configuration. This table is divided into 4 blocks corresponding to the first 4 sublevels S, P, D and F. The table is divided in 7 rows going across and called periods, ended in columns called groups and going down. Each period indicates the energy levels or shells occupied by the electrons of an atom of that element, and according to the group in which an element is included, there is a definite number of electrons in the outer shell of an atom of that element. All elements belonging to a group have similar chemical properties. When you move in a period or in a group, there are also changes in the properties of the element. One of these is the atomic radius. Atomic radius is defined as half the distance between 2 adjacent atoms of the same element. We use it to measure the size of atoms of different elements, but above all it's fundamental to explain the interactions of the atom. An orbital is a region of space where the probability of finding an electron is over 95%, so we can't exactly know the position of the last electrons, and that's why we use atomic radius as a standard size. In the periodic table, atomic radius tends to increase by going down in a group, and it tends to decrease by moving from left to right in a period. It means that the atom with the lowest atomic radius will be at the top on the right of the periodic table, and the one with the largest will be at the bottom on the left. Moving in a period from left to right, elements become respectively alkali metals, not including hydrogen, alkaline earth metals, transition metals, semi-metals and non-metals. Furthermore, going left to right, there is an increase in the ionization energy, that is the energy needed for removing an electron from the outer shell. Electronegativity also increased by moving from left to right. Both electronegativity and ionization energy decrease moving down in a group.
This is all for today. I hope you enjoyed the video.